What happens if a bowling ball and a tennis ball are dropped from the same height? Let's say the bowling ball weighs 7 kilograms and the tennis ball weighs 58 grams. Which one hits the ground first? In many polls, over 80% of people predict that the heavier object will fall faster. It feels intuitive. It feels right. But in the world of physics, intuition can be a trap. Let's run this test together. You'll see that, yes, the heavier one hits the ground first, with a difference of about 2.2 seconds. When we drop them in our everyday world, it often seems like the heavier one wins. But this isn't just because of gravity. There is a hidden player in the room: air resistance. Under normal conditions, this hidden force makes our acceleration slower than the ideal case. If we only look at gravity, we might fall into a mathematical trap. We think more mass means more force, so more speed. But we forget one critical thing: inertia. Now, what happens if we remove the air entirely? Imagine a perfect vacuum. No molecules, no drag, just pure, uninterrupted gravity. See, they fall with the same acceleration. So the question is, why do different masses have the same acceleration? Let's take two balls, one at 1 kilogram and one at 10 kilograms. According to Newton's second law, force equals mass times acceleration. In a vacuum, because there's no air resistance, the only force acting on the object is gravity, which is mass times g, gravitational acceleration. Now, when we set these equations equal, the masses cancel out from both sides. We arrive at a beautiful, simple result: A equals g. That means in a vacuum, your mass doesn't matter, 1 kilogram or 10. The acceleration is the same. Remember, the greater the gravitational force, the greater the inertia. So, more mass doesn't necessarily mean faster acceleration. Now, let's go back to the real world. Think of a feather and a ball. Do they have the same acceleration here? Let's analyze it. According to second law of Newton's, we now have two forces: drag and gravity. We know that drag depends on the object's speed and surface area. When a feather is released in the real world, as it starts accelerating, its speed increases. But because it has such a huge surface area relative to its tiny mass, it quickly reaches terminal velocity and enters a state of equilibrium. Since its mass is so small, the drag force balances gravity very early on, resulting in a much slower fall. So, we've learned, if there were no air, our acceleration would always be g. But because air exists, our actual acceleration depends on the object's mass and geometry. Thanks for watching! Don't forget to like and subscribe for more deep dives. I love you guys. Bye!